Hello everyone, this is Akshay Jain and in this video we are going to discuss Banker's algorithm in operating systems, a fundamental algorithm for deadlock detection and avoidance. Let's see Banker's algorithm. First of all, what is Banker's algorithm? A resource allocation and deadlock avoidance algorithm, also used for deadlock detection. This is a fundamental algorithm for the detection of deadlock and for its avoidance. It is developed by Edster Dishets. It tests for safety by simulating the allocation of predetermined maximum possible amounts of all resources. The bank analogy. The banker's algorithm, as its name says, it's derived from a bank analogy. It mimics how a bank manages cash to ensure it can always satisfy the needs of its customers. Like in a bank, a system is there to not make any customer wait. It's also used in banker's algorithm, the likewise system that we see in banks. Let's see. Why is it used? So it is used for the prevention of deadlocks, ensures the system never enters in an unsafe state. We'll later also understand what is unsafe and safe state. Resource management efficiently manages multiple instances of resources type CPU, RAM, printers. Also used for safety sequences. It identifies a specific order in which processes can execute to completion without locking the system, that is not causing the deadlock. Dynamic checking. Every time a process requests the resources, the algorithm test drives the allocation to see if it's safe. Every time there is a new request from a user, this algorithm ensures that any resources are free or not, or they should be given or not on basis of some system which we will see later in the video. Let's move on to defining the data structures we use in this algorithm. uh, Available, a vector of length m indicating the number of available resources of each type. Max, and n into m matrix defining the maximum demand of each process. Allocation, and n into m matrix defining the resources currently assigned to each process need, and n into m matrix indicating the remaining resource needs. Formula: v minus maximum resources from allocated resources to examine the needed resources. So let's see a practical example of it. Uh, Now here consider a system with 10 units of resource A. Here we can see we are given that there are 10 units of resource A, in out of which 5 resources are given to P0 process, 2 resources are given to P1 process, and 2 resources are given to P2 process. Here the total available is one unit of resource is available. Now max demand for them is, for process 0 the max demand is 10, and that tells us the need which we minus is the allocated resources from max demand, which we get 5. Same in the process P1, max demand is 4, allocated resources are 2, and we get the needed resources 2. Same in the P2, the max demand is 9, the allocated resources are 2, so we get the needed resources equal to 7. 9 minus 2, 7. So here the current available resource is 1 unit. System, now the system checks if it can satisfy the process needs. Now like we can see here, the needed resources for process P0 is 5, and we have currently available resources only unit 1, one unit resource, so it cannot definitely satisfy the P0 process. So we move to P1 process. Now P1 needs 2, it can be satisfied after some time releasing its 2 units. Now if the available resources moves to 2, then this process of P1 can be satisfied after some time, and if it's satisfied, then the allocated resources of its, which we can see on a screen allocation is 2, so these resources will be freed and will be added to the total amount of available resources. So the previous available resources were 2, and which enhances to 1 plus 2. 2 are freed of P1, which were added to the previous allocated resources and makes the count to 3 available resources. Now new available becomes 3 and eventually all processes finish. It's just an example. In this example it is not satisfying any process, but if there were needed resources were less, then it can satisfy the equation. This is how we calculate the assumptions for our bankers algorithm. I hope you understand that, and thank you for watching the video.